Two pointers is one of the simplest patterns in programming and one of the most useful. Today we'll cover what the pattern actually is, the two main variations, opposite ends and fast and slow, three classic problems they solve, and finally, when two pointers is the right tool for the job. The core idea is just this. Instead of nesting two loops, you keep two indices and move them through the array with a rule. Opposite ends. One pointer starts at the front, the other at the back, and they walk toward each other. Same direction. Both pointers start at the front. One moves faster than the other. Either way, you turn an O of n squared brute force into O of n. Here's the opposite ends pattern in action. Two pointers, left and right, bracket the array. You compare the values they point to. Based on the result, you move left forward, right backward, or both. Each step rules out an entire row of the brute force table. That's why O of n times n collapses into a single pass. Here's the classic problem. To sum on a sorted array. Given a sorted list and a target, find two numbers that add to the target. Left starts at index 0, right at the end. If the sum is too small, we need a bigger number, move left forward. If it's too big, move right backward. If we hit the target, done. The sortedness is what makes the decision unambiguous. Same pattern, different problem. Is this string a palindrome? Left and right at the ends, walk inward. At each step, compare the characters. If they ever differ, it's not a palindrome. If they meet in the middle, it is. Constant extra space, linear time. One of the cleanest uses of the pattern and a frequent warm-up interview question. Same direction now, the fast and slow variant, also called Floyd's tortoise and hare. Both pointers start at the head. Slow moves one step, fast moves two. If the linked list has a cycle, fast will lap slow, and they'll meet. If fast reaches none first, no cycle. A constant space, linear time. This is the standard way to detect cycles in linked lists without a visited set. When should you reach for two pointers? When the data is sorted, or you can sort it cheaply. When you're searching for pairs or triples that satisfy a condition. When the brute force has nested loops and you can avoid them by walking with intent. Avoid it when the problem genuinely needs every pair, and use a hash map when sorting isn't free. Two pointers is one of those patterns that looks obvious in hindsight, but transforms how you solve problems once you spot it. Once you can see it, you'll see it everywhere. Next up, the close cousin sliding window. Same idea, but the pointers stay together as a fixed or growing range.